In Preview Activity 5.1, we're going to draw a graph of f of x as best we can, given what we know about the derivative. So one of the things we know right off the bat is that we are told that f of 0 equals 1. So let's mark that on our graph here. Now part A says on what intervals is f an increasing function and a decreasing function. So let's do our number line like we did in the last chapter. So if up here we'll check f prime, and down here we'll see what's going on with f. So if we find the zeros, we see we have one here at 3/2. We have one here at 4. And the derivative goes positive, negative, positive. So that means f's going to do increasing, decreasing, increasing. So there's our intervals of increasing and decreasing. Concave up and down is going to be we're going to use a similar method. Now here, whenever the rate of change is increasing, it's going to be concave up. Whenever the rate of change is decreasing, it's concave down. So concave up, we can see 0 to 1 and from 3 to 5. Concave down from 1 to 3 and from 5 to 6. Now, do we have any relative mins or maxes? Well, look, at 3/2 we're going to have a relative max because the function is going to go from increasing to decreasing. At 4 we're going to have a relative min because it goes from decreasing to increasing. So what we'd like to do now is find some function values. Well, what we're going to do is the fact that we know, we'll do this for 0, 1, and then you'll kind of see how we're going to look at this. The integral from 0 to 1 of f prime of x dx is f of 1 minus f of 0. Okay? Well, remember, this is the area underneath the curve. So what we need to do is get the area accumulated between each point. So if we look at this triangle, it's got a base of 1, a height of 1, it's got an area of 1/2. So what that tells me is this has to equal 1/2, and think about what we know. We're looking for f of 1. We know that f of 0 is equal to 1 because we were given it. So f of 1 equals 3/2. What that does is that gives us a point, or 1.5, that we can plot. And we're going to continue to do that. So we're going to look at the accumulation. Let's do from 1 to 2. The area of this triangle is 1/4, but then we're also losing a 1/4. So the total accumulation between 1 and 2 is 0. So at f of 1 we were at 3/2. We're going to go up or down 0. So f of 2 is going to be 3/2 again. Well, that actually makes sense because remember we said we had a max at an input of 3/2. So we know that there's going to be a point right there. It goes up a quarter and down a quarter back to the 3/2. Now here, if we look between 2 and 3, we could break this up if we like. We got a square of 1, and then a triangle with a height of 2 and a base of 1, so that's got an area of 1. So the area here is -2. So that means our change in position between 2 and 3 input units is we're going to go down 2. So we were at 3/2, and we're going to go down 2 to 1/2. So just to keep track, f of 3 is -1/2. We're going to do this again. This triangle here has a height of 3 and a base of 1. So the area here is -3/2. So we're going to go down again to get to 4. And we're going to go down by 1.5. So that's going to move us all the way down to -2. So we know that f of 4 is -2. So what we're doing is we're getting to each next point by looking at our change in position. Right here, we are going to go up by again, we have a triangle, the height of 3, a base of 1. This area is a positive 3 halves. So from here, we're going to go back up 3 halves. So that's going to put us about right here. So f of 5 equals negative 1/2. We can do the same thing to get to f of 6. Again, this has an area of 3 halves. So f of 6, we're going to go up 3 halves from here, which puts us right about there. Now, so f of 6 equals 1. We're finally ready to draw our graph, but we're going to pay attention to our concavity. We said it was concave up from 0 to 1. And then concave down from 1 all the way to 3. So we want concave down as much as we can to this point. Okay, so we're trying to hit our points and get a little bit of concavity in there. Now from 3, only to 3. Now from 3 to 4, so ignore this right now. From 3 to 4, we go back to concave up, decreasing but concave up. Here's our relative min that we had seen earlier. And now that's going to be concave up to 5. And now we got decreasing, so it's going to be concave down again. So we can see a rough sketch of our graph with my little error in there. Let's concave down to 3, concave up to all the way to 5, and there's our min. Here's our relative max that we had seen earlier, and then concave down to finish out. Now, it said when the x is less than 0, the derivative is 0, so there's no change. And when x is greater than 6, the derivative is 0, so no change. So there's how we can begin to draw a graph of a function given the derivative, and using this idea of area and accumulation that we looked at in Chapter 4.